Hello, this is Gabe Rogers, and today we're doing Physics 2, Lab 1, which is charged tapes. So on the table of contents, we'll go over the introduction, which is the fundamental ideas, the formulas used, and then we'll go over the model, and we'll explain the code and the program simulated model that we used, and then we'll go over the results, especially going over what the magnitude of the charge of the piece of tape was, and the assumptions, approximations, and idealizations made in order to reach a result. And then we'll go over additional questions about what happens if the electrons or protons switch charges, and then why is it important to handle the charges as little as possible. So the fundamental ideas we'll discuss is Coulomb's law, which will be explained in the formula slide, next slide, the electric field, and the force due to gravity's Earth's gravity, are the fundamental concepts we'll be dealing with. For the formulas used, we'll be using Coulomb's law, which is the electric force is equal to K, which is equal to 9 times 10 to the 9th power, times charge 1 times charge 2 over the distance of separation between the two forces squared times the direction vector, r hat. And then for the gravitational force, we calculate that by 9.81 times the mass of the object to calculate gravitational force. So in our results, we have it that the top charge value, which is the tape that's being repelled by the bottom tape, is in equilibrium, since the you can see that electric force and gravitational force is the exact same pretty much, and so the magnitudes are the same, so that's why it's able to stay in equilibrium. And so the assumptions and approximations and idealizations about this result is that we ignore air resistance, we treat tape as a charge point, and then we assume that the tape has the same amount of charge evenly distributed across the tape.